Number 47, how can the pressure of water vapor be increased in the following equilibrium? And then we have this equation right here. So they give us that we have H2O liquid coming in equilibrium with H2O gas, and we have a delta H value. Okay, so the Chateliers principle, they give me a delta H value. The first thing that I'm going to do is I'm going to talk about this in terms of heat, whether the heat is on the left side or the right side. Now, they told me that the delta H, which is enthalpy, right, was a positive 41 kilojoules. I don't care what number it is. The only thing I care about is that this was a positive number. Since this was positive, that means that this was an endothermic reaction. And remember, back when we did the enthalpy chapter, endothermic means that you absorb heat. And when you absorb the heat is always going to stay on the reactant side. If this was a negative and it was exothermic, the heat would be on the product side. So I know that I have plus heat over here. And once I state that, I could care less what number this is. Now I have everything that I need to answer the question. Now in this case, we want the water vapor to be increased. This is the water vapor. Remember, vapor is a gas. It's steam. In this case, H2O gas is steam. So if I want to increase the water vapor, would I go in the direction of the forward reaction or would I go in the reverse reaction? If I want this to be increased, I want to go in the forward direction, right? By going to the products, I will increase this. Okay. So now let's just suggest a way in which we do that. Since they gave us a delta H, the easiest way would be to talk about is the heat, aka the temperature, right? There's two different ideas. Let's see which one is correct. So we could either increase the temp or we can decrease the temp. Which one of these would get us a forward reaction? Let's start with the increase in temp. Remember that if we increase the temperature, it is way too hot, right? And if it's way too hot on a really, really muggy, like a humid day, right? And you're outside. Me personally, that's not me. I'm going inside. If it's way too hot, I go away from the heat. I come inside. The same thing for chemical equilibria. Look for that word heat. If you increase the temperature, you are not going towards the heat. You are going away. And look there, guys. Did our arrows match? Yeah. So how can the pressure of water vapor be increased? All you got to do is just increase that temp. If we did the decrease in temp, you would see that it would be the reverse direction. And that's not the answer. So I'm just going to erase this. So that answers the question. All you got to do is just increase the temperature. All right? So hopefully that helped. Let me know in the comments. Thank you so much for viewing the video. Subscribe to the channel. That will really help us out. And I really do thank you. And I appreciate you guys for watching and learning. And this whole journey has been so cool. You guys have been so kind in the comments. So I really, really do, appreciate that. And I appreciate you. All right? Let's keep learning. And I will see you in later lessons. Bye-bye.